In this video, we're going to do some end behavior practice problems. For the first problem, we're going to fill in the table. So our first function is f of x equals 3x squared plus 2. My highest exponent in that polynomial is 2, and the coefficient for the term with the highest exponent is 3. So 2 is the highest exponent, then I look at the number in front where the exponent is 2, and that is 3. So what that means is that my highest exponent is even and the coefficient is positive. Now I could either remember this or I could scroll down all the way past the rest of the problems here and find the shape that matches with that. So my degree is even and leading coefficient is positive, so that means that the graph is going to look like this. So it's going to go to positive infinity on both sides. So as x gets more negative, f of x approaches infinity. As x gets very large, f of x approaches infinity. The second problem is f of x equals negative 2x to the third plus x minus 2. So my highest exponent is 3. The coefficient for the term with the highest exponent is negative 2. So my degree is odd, and my leading coefficient is negative. So my degree is odd, leading coefficient is negative. That's going to be this case. So it's going to rise on the left and fall on the right. Or as x gets more and more negative, it's going to go to positive infinity. As x gets larger and larger, it's going to go to negative infinity. Question 11 says to describe the end behavior of the graph to the right. So this graph, I see that it's rising on both sides, rising to the left and rising to the right. Or I could say that it approaches infinity as x gets more negative and as x gets very large. Question 12 says, is it possible for this graph to have a degree of 5? Why or why not? So if a graph has an odd degree, that means that the end behavior is pointing in two different directions. So one side is going to be going downward, one side is going to be going upward. So it's not possible for this graph to have a degree of 5. It has to have an even degree because both sides are rising, or both sides are approaching infinity. Question 13. Which of the following terms, when added to the given polynomial, will change the end behavior? Highlight all that apply. So we know that the end behavior depends on the highest exponent and the leading coefficient, or the coefficient for the term with the highest exponent. So we want to look for things that would change what that is. So if I add a, I can see that yes, that is going to change the end behavior, because it's going to change from something with an odd degree to something with an even degree. So that would change the end behavior of the graph. B is not going to change the end behavior because it's not going to change what the largest exponent is. C is going to change the end behavior because it won't change what the highest exponent is, but it will change what the leading coefficient is. It will change from negative to positive. So if it changes from negative to positive, that's going to change which direction the arms of the graph are pointing. D, even though 1,000 is a pretty large number, is not going to change the end behavior because it's not going to change, again, the degree or the leading coefficient. And E, same thing, will not change the degree or the leading coefficient. So my choices are A and C. Question 14 is a matching question. So I want to match the polynomial to the graph, and I do this based on the end behavior. So looking at number 1, I can see that I have an odd degree. the degree is 3, and my leading coefficient is negative. That means that the directions of the arms are going to be going in opposite directions, and the overall graph is going downward. So that's going to match with answer choice C. Number 2 also has an odd degree, but this time the leading coefficient is positive. So arms are pointing in opposite directions, and it's going overall upward. So that's going to match with graph A. Number 3 has an even degree and a positive leading coefficient. So that means that the graph is going to be pointing in the same direction, and since it's positive, they're both going to be pointing upward. So that would match with graph D. And finally, number 4 has an even degree and a negative leading coefficient. So going to be pointing in the same direction, and because it's negative, they're both pointing downward. So that's going to match with graph B.